Hello and welcome to another video lesson. In this week's video lesson, we're going to talk about object-oriented programming and classes in Python. So before we dive into the new material, let's quickly discuss what we've been doing so far this semester. Up until now, we've been working within the procedural programming paradigm. And in this in this way of programming, we write code that tells the computer what to do step by step. It focuses on functions that manipulate data, and every function and variable you create has a specific purpose, and your program runs from the top down. This is a linear way of thinking about organizing code. So for example, we've written functions to calculate values or to print out results, and each of these functions is a separate step that performs one special task. Now, in contrast to procedural programming, we're going to explore object-oriented programming, or OOP. It's often abbreviated as OOP. And this is a way of thinking about organizing code that's different from what we've done so far. So instead of focusing on just functions and procedures, we organize our code into objects. An object is a collection of related data and functions. It's like bundling your data and the functions that interact with that data into a neat, tidy little package, which we're going to call a class. This method allows us to model real-world entities more naturally and organize code in a way that's easier to maintain, easier to scale, easier to think about, easier to reuse. You might ask yourself, well, isn't OOP just procedural programming with objects? And the answer is not really. Procedural programming focuses on writing sequences of instructions and functions that manipulate data, while OOP organizes code around objects that contain both data and the behaviors that act on that data. And this helps to make code more modular and reusable and easier to manage as our programs become bigger and bigger. So procedural programming is like giving the computer a recipe or a list of steps to follow. So you write functions that operate on data. Data and functions are separate, and the program's flow is mostly linear or controlled by function calls. Whereas in object-oriented programming, the focus is more about bundling data and behavior together into objects. You create classes that define your objects. Objects encapsulate both data and functions. You model real-world things and their interactions, and we promote concepts like encapsulation and inheritance and polymorphism, which we will dive more into next week. So let's discuss a little bit more before we begin. What is an object? So let's try to break that down. An object is simply an instance of a class, and a class is like a blueprint for creating objects. So as an example, let's imagine we want to model a dog in our code. We could create a dog class. Now this class is going to be the blueprint, but we need to create actual dogs. These are going to be the objects from this blueprint. And an object contains two main things. Attributes, which are also called properties, are the characteristics of the object. So for example, a dog might have attributes like a fur color, a tail type, a name, a size, and methods. These are behaviors or actions that the object can do. So for example, a dog might have methods like bark, eat, sleep, bite, or maybe not bite if your dog doesn't bite, if you'd rather have it that way. So next we'll go ahead and we'll dive into the syntax for creating a dog class. Okay, so the first thing we want to do is we want to use the keyword class, and it lights up because it is a keyword. Let me minimize this function here, or this folder here. And then we want to name our class, and we're going to name our class dog with the D capitalized. When you create classes, when you're naming classes, you want to the first character of the name, you want it to be capitalized. This is the standard convention. And then we put a colon and hit enter. And we are going to create a constructor. And we'll talk a little bit about what this is in a moment. 2 underscores, the word init, 2 underscores again, and then parentheses. Now the IDE I'm using automatically enters the self keyword into the parameter section of this function, which is going to be a constructor. Then I'm going to put a comma because we want our dog to have more things than just its own self, right? Its own instance of itself. We want it to have a name. We want it to have a fur color. We want it to have a tail type. And we want it to have a size. So a really basic dog that has a name, a fur color, a tail type, and a size. And we need to create a way to initialize these values as whatever the user put. So we will type in self dot name first equals name, whatever this is, whatever the user put when they created the dog object. That's what this instance of this dog, that's what its name is going to be. And we'll do the same thing for the other attributes. So self.fur color, self.tail type, and then self.size equals size. Okay, that looks pretty good. And we're going to create a couple of methods, behaviors for the dog. So we want all dogs to be able to bark, so DEF, and then make sure that you line up this def with this def keyword. So we're outside of the constructor. So outside of the constructor, this is just this is for instantiating a new dog. This is the behavior. These are the behaviors associated with this dog. So bark takes itself, and then we just want to print, let's use an F string, and then we'll use whatever the name of the dog is, and then we'll say is barking. So self.name is barking, right? Instead of just saying the dog is barking, which is fine, you could do that. Let's access whatever this instance of a dog's name is and say that it is barking. And let's do the same thing with eating. So eat. So we'll give it the eat behavior as well, and we'll say print, and then we'll use an F string, and then we'll do the same thing. And then we'll say that they are eating. Okay. So this code shows a class called dog, and inside, let me lower this a little bit so you can see better. And inside the class, we have an initializer method, this right here. This, the init part is the constructor. This method is called whenever we create a new object in memory, a new dog object in memory, and it sets the initial state of the object using the attributes. So to note here, it's not technically required to define a class with the constructor, but it's almost always used when your objects need to start with some data. And it's good for us to get the practice with that. Our dog class also has two methods, bark and eat, and these define the dog's behavior. So to discuss just a little bit more about this syntax, because I think it's a little bit jarring for students, and we'll also discuss this, but let's go ahead and talk about this a bit. The init method, this thing right here, so again, it is the constructor. It is a special method in Python classes that automatically gets called when a new instance of that class is created. Okay, so I just want to drill that in and make sure that you understand that. So now let's talk about self. So when you define a class, you are creating a template for objects, but each object needs its own unique set of data. Part of the cool thing about classes is that you create a template for making multiple of these, and all of those dog objects will be able to do the same things. They'll all be able to bark, they'll all be able to eat, and you'll be able to give them their own attributes, so for each unique dog. So instead of having to code all of this stuff up again, you just need to instantiate a dog, and I'll show you how to do that soon. And you can have all of these behaviors and attributes for each individual dog. This self keyword, think of it as a way to reference the current instance of the class, which is the object being created. So think of self as a way to say this method or this attribute belongs to this specific object. So that's how that is. That's how that works. So the self part ensures that each object has its own set of these attributes, tail type, size, fur color, even if they all come from the same class. And in a constructor, we can do more than just setting attributes. We can also call other methods inside of the constructor. We can perform validation. We can edit the arguments that the user entered when they instantiated a dog object. We can set default values. Like if a user doesn't put a name for color, tail type, or size, we, automatically have a default value. Okay, the fur color is automatically going to be black. The tail type's automatically going to be straight, et cetera, et cetera. So I think we can expand on what we have here just a little bit. So let's go ahead and create a print statement that tells us when we call the constructor that we've created a dog using the dog's name. That's quite fun. So we'll use an F string and we'll say self.name. The dog is created and it's a happy thing. Also, maybe we shouldn't shout at our dog. Let's put a period here. If we're just like this dog is barking and we're exclaiming, it's kind of funny. So we'll just put periods here and we'll get really excited when we make the dog. Okay, so yeah, so we can create an output that signifies that we've created a dog. And we can also, like I mentioned before, perform validation, edit arguments so that they match format that we want to have. So for example, like let's say a user, when they instantiate the dog and they enter in the name for the dog, let's say that the first letter of that name is not capitalized. And we know that with names, normal naming convention with like people, places, and things, we usually capitalize that first letter, or people and places, not just things. So to capitalize and ensure that the first letter is capitalized, we will create a conditional statement. We'll say if, right, self.name, and then we want to examine the first character, right? The first character would need to be capitalized. We learned string methods a couple weeks ago. And to access the first character of that string, we use the index 0. And then we can use some string methods like isLower. So if the first character is lowercase, we want to uppercase it, and we want to say that is the name. That's what we're going to call it. It's not, this dog's name with the first character lowercase. It's the correct way to do it. So we'll say self.name equals, and then we need to capitalize the first character. So we will do this, and we will use the string method upper to capitalize it, plus the name, and then we'll use string slicing. Remember, we learned how to extract parts of strings. So from index 1 on, right? That's what this means. So we start at 0, so that's the first letter, and then 1 on, that's going to represent the rest of the name. Combine it, concatenate that, and then that should be correct. Okay, I don't want to get too carried away and make too many methods and attributes and validation methods. Like, I don't want to get too carried away with it. I just really like dogs. So let's move on. Let's go ahead and look at a way to instantiate the dog object. So now that we've defined our class, we have methods, we have attributes. So we have both of those things. Now we can instantiate the dog, a dog object, to create individual dogs. And I keep using that word instantiation. When we talk about classes, instantiation is the process of creating an object from a class blueprint. So to do that, here's the syntax. We would say, so we want to refer to this as my dog in the code. We want to refer to it as my dog, so whatever you want to refer to the object as. And then an equal sign, and then the name of the class. Let me see if I can scroll down so you can see better. Dog with a capital D, syntax matters. And then we need to start adding arguments. So this dog will have a name, a fur color, a tail type, and a size. And we want all of these to be strings, so string attributes. So we will put in quotes the name of the dog. I'll go ahead and I'll put the name of my dog, Snubbles. She's a pug. I've mentioned her before. Okay, so we have a name, a fur color, a tail type, and a size. So we will say her fur color is black and tan. And then depending on what IDE you're using, if you're using an online compiler, if you're using a dedicated IDE, you might get these prompts here, which make it a little bit easier to enter in information. This one's prompting me for fur color, prompting me for name. Really just depends what you're using. I'm using PyCharm. We want to enter her tail type, which is curly. She has a little seashell tail. And her size, she's small. She's a little dog. So this is going to create a dog object, and its attributes are going to be, here's the name, Snubbles, the fur color, black and tan, the tail type, curly, and the size, small. So I'm going to run this. And then you'll see here, it says Snubbles the dog is created. So the constructor got called, and it looks like, everything went well. Our program didn't crash. We didn't get an error. So that's how to do that. And if I wanted to access any of the attributes of the dog, I can do that by saying, I might want to print this, of course, so it's outputted so we can see the result. You would say the name of that dog object in your code, dot, and then you kind of see a little bit about, you kind of see these recommendations here for color, name, tail type. Use the dot operator to access attributes and to access methods of that class. So I want to see her tail type. So what kind of tail does she have? So we'll run this, and then it says curly, right? Dog was created, curly tail. And then to access the methods, right? Here, I'll get rid of this for now so we can keep things nice and clear and neat. To access the methods, the behaviors of the dog, you would do it very similarly. So my dog, the name of the dog in code, dot, use the dot operator, and then we want to say what method we want to call, and then the parentheses. And then this doesn't take in any arguments. We don't need to put anything here. So I'll go ahead and run it. And then it says Snubbles is barking, right? And that's one of her behaviors. Again, if we want to access her eat behavior, we go ahead and run it. Snubbles is eating. Okay, simple enough. So we use the dot operator to access the methods and the attributes of the dog. At this point, I think it's worth talking a little bit more about object-oriented programming and some of the concepts in object-oriented programming. So one of the core concepts in OOP is encapsulation. And encapsulation is the idea of bundling the data, which here, we have the, let me scroll up here, the attributes and the methods, which are these functions here, that operate on the data together in one class unit, right? So we've bundled all of the attributes and all of the methods associated with this class together. It's very neat, it's very tidy. But encapsulation also includes a concept known as data hiding. Sometimes we want to restrict access to certain attributes to prevent accidental or unauthorized changes. So you might think about some of programs that you've used before, right? Or some applications that you've used before. You don't want access to certain information that might be harmful. You don't want users to be changing information certain bits of information, because it might change the behavior of your application. It might lead to unpredictable behavior. It might crash the program. So to do this, we can make attributes private by using double underscores before the attribute name. So currently, all of these attributes are considered public. So we have access to these. We have access to these attributes through the class in a very simple way. We just say my dog and then name. We're just able to home. We're just able to get these attributes just through the class, right? Through the class dot operator. So if we wanted to create a private variable, something that we can't do that with, we would say self.balance. So we'll create a private variable. It needs 2 underscores before it for it to be private. And then we'll say 100. So all dogs, upon instantiation, whenever we create one, all of them have a private attribute called balance. And all of them, it is set at 100. This is default behavior, like we were kind of mentioning at the beginning of the lesson. But this is a private attribute. So if I tried to, let me get rid of these things here. If I tried to access it, so I'd say balance, right? If I try to do that, and then I would say print. I can't do that, right? And then I could probably try to put a couple underscores ahead of it. I can't do that either. It doesn't want me to do that. So in this case, the balance attribute is private and it can't be accessed directly from outside the class. So instead, we need to create a special method, a getter method, to retrieve the value safely, to grant access to this variable, at least to look at it. So to do this, we will create a method called a getter. So our getter will be called, so first put the keyword def, get under, no, let's do camel casing, get balance. And then we want a way for the user to get whatever this dog's balance is. So we'll return, I believe I need to use self underscore balance. There we go. So this should allow us to get whatever the value of balance is for the dog object. So at this point, we can say print my dog and then use the method that we created, which is get balance. And then I run this, and then you'll see it's 100 here. So, this method, get balance, is known as a getter. And it's a fairly common type of method in classes. So the getter is also sometimes called the accessor, and it's a method that retrieves or returns the value of an attribute. You also have another concept that you will cover in your labs called a setter or a mutator. And it's a method that allows changes or updates to the value of an attribute. So by using getters and setters, you control how the attributes are accessed and how they are modified. So, okay, after all that, so we went over a lot. Let's recap what we covered in the lecture. So we started talking about what we've been doing so far, which is procedural programming, where we write code step by step. Then in this lesson, we're shifting to object-oriented programming, which organizes code into objects that model real-world entities. In this case, a dog, right? That's a real-world entity. We discussed what an object is, an instance of a class, and how it consists of attributes and methods that are bundled together. We learned how to define a class, instantiate objects from it, and define methods like getters. And then finally, we covered encapsulation and data hiding to keep object data secure and maintainable, and control how that data is accessed or changed. So in the next lesson, in the next module, we're going to expand on the topics that we covered today. So make sure to get plenty of practice. Thank you so much for listening and have a wonderful day.